Alright, we're going to talk about how to write and name ionic compounds. We'll start with the most simplest form. So this will be what we call binary compounds, where you have a single metal and non-metal. So remember, ionic compounds are when you bond a metal with a non-metal. So in order to write to name a binary compound or ionic compound, the positive ion, the cation, goes first, and we keep its full name. The negative ion, or the non-metal, goes second, and it changes its last or its end of its name to IDE. So for example, we would take chlorine and we would change that to chloride. All right, so forming binary compounds. So I'm going to draw the Lewis structure of sodium and chlorine. So here's sodium. Sodium has 1 valence electron. Chlorine has 7. And so that sodium wants to donate its electron. Chlorine wants to add an electron. So there you go. Sodium is able to donate its electron to chlorine. When sodium donates an electron, it'll form a +1 charge because it loses an electron. Chlorine will become negatively charged by 1 because it gains 1 electron. What you'll notice is the positive and negative charges attract each other, and so they form a single compound called NaCl. Some people put the 1s here, but the 1s are not necessary. We just assume that there's 1 sodium to 1 chlorine, and the name is sodium. Remember, the cation always goes first. And the second one is chloride. Remember, chlorine is our anion, and our anion, we take off the ending and the INE and add IDE. What I would like you to be able to do is, when you're solving these, is determine the charge for each particular cation, anion. For example, sodium, we know, has 1 valence electron and wants to get rid of it, so it's Na+1. Chlorine has 7 valence electrons, so in order to follow the octet rule and be stable, it needs to add 1 more to get to 8. Remember, we either want to get to 0 or 8. In sodium's case, we removed an electron to get to 0. That's stable. In chlorine, we want to add an electron to get to 8, so it's stable, right? Chlorine is closer to 8. Sodium is closer to 0. That's why we go to 0 and versus chlorine going to 8. So adding an electron is chlorine -1. So we'll see Na+1 and chlorine -1. In this case, it's going to be a 1-to-1 ratio because our ionic compound is neutral. So +1 and -1 kind of cancel out. So we just have sodium chloride. Okay. All right, our next one. We're doing lithium with oxygen. Lithium is in group 1, so therefore has 1 valence electron. It wants to get to 0, so lithium is going to be a +1 charge. Oxygen has 6 valence electrons. It's closest to 8. All it needs to do is add 2 more electrons. Adding 2 more electrons makes it more negative. So therefore, we have lithium +1 and O -2. Remember, when we combine these two, we want them to be neutral. But if I have a +1 charge and a -2 charge, you'll see that it's not going to be neutral. And so what we need to do is add a second lithium, because that adds another +1 charge. So the total here is now +2, which will counteract or neutralize the -2 on oxygen. So for every lithium, we can see there are 2 lithiums. So I go Li2. The subscript 2 there shows that there are 2 lithiums for every 1 oxygen. The name of this is lithium oxide. Notice when we name it, we don't really care about the subscripts. We just write lithium and then oxide. Let me show you what exactly is happening. So what's happening or occurring here is that oxygen needs 2 more electrons in order to be stable. Lithium wants to remove its 1 electron. Lithium donates that electron to oxygen. Lithium's happy, but oxygen isn't because it needs 1 more. It now has 7 valence electrons. So another lithium comes along, donates its electron, so you get full. Now everybody's happy. Oxygen has 8, lithiums have nothing. So for every 2 lithiums, you need 1 oxygen. Let's look at the next one. Might be good if you tried this on your own. You can press pause and then play when you're done. So in this case, you have aluminum. Aluminum has 3 valence electrons, so it's going to lose its 3 electrons to become Al plus 3. Sulfur has 6 electrons, so that's closer to 8. It just needs 2 more, so S minus 2. It needs 2 more electrons, so let's go ahead and compare the two. I have Al plus 3, S minus 2. Now if I combine these two, it's not going to be neutral. It's actually going to be more positive. So I want to make this more negative. I'm going to add an extra sulfur minus 2. This makes it negative 4 compared to the plus 3. It's still not neutral, and so I'm going to add another positive because it's too negative right now. So this is plus 6. You'll see that now it's too positive, so I'll add one more negative, and this comes out to negative 6. So these are all neutral. So in order to be neutral, you'll see that I need 2 Als and 3 S's. This is aluminum sulfide. Okay? So you can add as many as you need until you're neutral. Alright, just go ahead and try these. So I give you the name, and then you write the formula, and I'll go ahead and go over it. Cesium is Cs, so Cs with 1 valence electron is Cs plus 1. Nitride is nitrogen, right? Remember, you have to remove the ending and add IDE. So this originally was nitrogen. Nitrogen has 5 valence electrons, so this becomes N minus 3. Nitrogen needs 3 more electrons to get to 8, right? All right, then I compare the two, Cs plus 1, nitrogen minus 3. Well, you'll notice they're not neutral, so I need to add more plus charges. If I add 2 more, that gives me a total of 3, right? And so it'd be CS3 and strontium oxide. Sr is 2 valence electrons. This would be a plus 2 charge. I want to remove those 2 electrons. Oxygen has 6. This would be negative 2 because it needs 2 more electrons. Sr plus 2 and O minus 2, they're already neutral, so I just need 1 to 1, right? Here is the homework.